Hello and welcome. Thank you for joining me. We're about to start lesson U2A6, where we'll go over the intersection of a line with a plane. Before we get started, I suggest you grab a piece of paper and a pencil or a pen and try to follow me through the different cases of how a line and a plane can intersect. So there are three cases. Number one is when the line gets through the plane and it will have one point of intersection in common. And case number two is when the line is parallel to the plane, there will be no common points, so no points of intersection. And case number three is when the line lies flat on the plane, which means that there will be an infinite number of common points, so infinite number of intersection points. So we're going to take a look at three different examples that illustrate each case so that we can see how the algebraic solution will represent or describe each case or will fit each case. The first example, number one, we are given the equation of some line in vector form and the equation of some plane in scalar form. And we want to find the intersection point. Now remember that any point on this line can be the intersection point if that exists. So what we're going to do is first derive the coordinates of any point on this line. So for this, we're going to write the coordinates x, y, and z of any point equals 3, 1, 2, plus s, 1, negative 4, negative 8. So let's derive the parametric equations or the equation for each parameter of this point. For x, we're going to have 3 plus 1s, so that's 3 plus s. For y, we have 1 plus negative 4s, so y equals 1 minus 4s. And for z, we'll have 2 plus negative 8s, so 2 minus 8s. We are going to substitute the coordinates x, y, and z of the supposedly common point into the equation of the plane. So we'll have 4. For x, we have 3 plus s. Plus 2, for y we have 1 minus 4s, and then minus z, which is 2 minus 8s, minus 8 equals 0. So solve the equation for s, 12 plus 4s, plus 2 minus 8s, minus 2 plus 8s, minus 8 equals 0. Collect like terms, so start off with s terms. So as you can see here, we have minus and plus 8s, which means we're left with 4s. And then for constants, we have 12 plus 2, 14, minus 2, back to 12, minus 8, 4. Take plus 4 equals 0, so take 4 on the other side. And that means that the value of s must be negative 1 for these three coordinates to fit into the equation of the plane. So with this s value, we're going to revisit the parametric equations and say that 3 plus s would be 3 plus negative 1, that's 2. 1 minus 4s would be 1 minus 4 times negative 1, which is 5. And 2 minus 8s would be 2 minus 8 times negative 1, which equals 2 plus 8, or 10. So therefore, we're going to say that there is a point of intersection, and the coordinates of it are 2, 5, and 10. Now let's move on to the next example. In the next example, we are given the equation of a line in parametric form and the equation of the plane in scalar form. Similar to what we did in the previous example, we are going to substitute the coordinates x, y, and z on the line, which are coordinates of any point on the line, into the equation of the plane. And let's see what happens. So here we go again. We have the equation of the plane 2x minus 5y plus z minus 6 equals 0. The x coordinate on the line would be 2 plus t, so we'll substitute x by 2 plus t, minus 5, for y we have 2 plus 2t, plus z, and for z we have 9 plus 2t. And then minus 6 equals 0. So let's solve. So we have 4 plus 2t minus 10 minus 10t plus 9 plus 2t minus 6. Obviously, you can simplify the 9 and the negative 6. I'm just going to leave them for the end. And here we have the like terms. We have 2t and then negative 10t and then another 2t here. And therefore, we're going to say we have 2 plus negative 10. This is 9 plus 8t, sorry. There we go. So we have 2 minus 10 plus 8, which equals 0t. For constants, we have 4 minus 10, negative 6, minus 6, negative 12, plus 9, negative 3. So we have 0t equals 3, which means that t must be 3 divided by 0. So in this case, we're going to say that t is undefined, which means that we don't have, or we couldn't find a t value that would help us define the coordinates x, y, and z of a point that can fit into the equation. So that means that such point doesn't exist. And when there is no point of intersection, we know that the line and the plane must be parallel. So therefore, we're going to say that the line L is parallel to the plane pi. Next, we're going to look at example number 3. In example number 3, we have the equation of a line given in vector form and the equation of the plane given in scalar form. Similar to what we did in the previous examples, for the line, we're going to derive the parametric equations, which will help us determine the coordinates of the point of intersection. 14, negative 5, and then negative 3. So we'll say that x equals 3 plus 14s, y is negative 2 minus 5s, and z equals 1 minus 3s. So 3 plus 14s. For y, we have negative 2 minus 5s. And for z, we have 1 minus 3s. And now we are going to go back to the scalar equation of the plane and substitute the x and y and z coordinates in the plane with the coordinates of any point on the line. So that means we have 3 plus 14s for x, plus y, which is negative 2 minus 5s, plus 3z, which is 1 minus 3z, minus 4 equals 0. So let's solve for s. We have 3 plus 14s minus 2 minus 5s plus 3 minus 9s minus 4 equals 0. Collect like terms. And what you see here is negative 5 and negative 9, making a negative 14 plus 14, 0s. For the constants, we have 3 minus 2, 1, plus 3, 4, minus 4, 0. So we'll say that 0s equals 0. And let's stop here for a moment and think what values of s can satisfy this equation. So basically, we're going to say any value of s can fit in. So if s equals 1, 0 times 1 is 0. If x equals negative 1 million, 0 times negative a million is 0. So we're going to say that this equation is true for any value of s, which means that any value of s means that there will be an infinite possible values of s that can help us find the coordinates x, y, and z for the intersection point. So therefore, we're going to say that the line L lies on the plane pi because there is an infinite number of possible intersection points. So I hope this made sense, and please follow through with for the second part of the lesson, where we will look at the intersection between a line and YZ plane. Thanks for watching.